This is the latest course MLC examination, the written answer section from the number 1. I will not be posting a written version of this, but this will be available in the online seminar that I run. But of course you can see the problem here, and the text of the problem is available from the Society of Actuaries, but let's take a look at it. We are using a 3-state Markov model to price a 10-year disability insurance product. There are 3 states: healthy, temporarily disabled, or dead. You can see that you can go from the healthy state, denoted by 0, to temporary disabled state, denoted by 1, or to the dead state, denoted by 2. Temporary disabled, you can go from that state number 1, back to healthy, or to dead state, and the first dead is absorbing. First step is show that for this model, the sum from j equal to 0 to 2 of the annuity payable continuously from age x for up to 10 years. Now this notation above 0j, that refers to an annuity that is payable as long as that life, now age x, is in state j, but given that that life is now in state 0, so healthy. And we're considering all 3 states, 0, 1, and 2, as you see from the sum. So we want to show that for this model, the sum of these 3 annuities is equal to the deterministic annuity payable over 10 years, A bar angle 10. And here's some more information. The product has the following features. The product is issued to an individual's age X who are in the healthy state. The product pays a continuous disability benefit at a rate of $1,000 per year, while the insured is in the temporarily disabled state. Now notice the payment of the disability benefit is continuous. The product pays a death benefit of $10,000 at the moment of death, so that's also a continuous mode of death benefit payment. Net premiums are payable continuously while the insured is in the healthy state. Continuously payable premiums, and they are net premiums. They only pay for the benefits. They don't pay for any expenses. There is no mention of any expenses. You are also given the following information. The force of interest is 10%. You are given the life annuities payable as long as that person is in life HX is in state 0 for 10 years, starting from state 0. So, and the payment happens only if the person is in state 0, but it's paid continuously while in that state. And that value is 4.419. Notice that this is actually not a very simple annuity to calculate, because it includes cases where the person continuously survives for 10 years, being healthy, but it also includes the cases when the person becomes disabled and then comes back to becoming healthy, and then this kind of annuity would resume payment at that moment, pay as long as the person is healthy, and then stop again if the person becomes disabled. Now, if the person dies, the annuity stops, of course, and it doesn't resume because the death state is absorbing. The second annuity is annuity payable while the person is disabled. If the person starts from a healthy state for 10 years, then we have this death benefit. Now, the strange notation 02, that simply refers to the death benefit being payable upon death, state 2, if the person is now healthy. And it's a unit benefit, payable continuously, because that's the mode of payment here. The force of going from state 0 to state 1 is 4%, or 0.04, while the force of going from state 0 to state 2 being death, is 0.02 t, so it increases with t. And then the force of going from state 1 to back to state 0 is 0.05, so it's constant. And finally, the force of going from state 1 to state 2 is 0.04 t, also increasing. And you can see that it's also higher than for the healthy state. So a person who is disabled is more likely to die than a person who is healthy. So part B says, show that the net premium rate for this policy is $970 per year to the nearest 10. You should calculate the rate to the nearest 1. Then we look at the reserve, net premium reserve for a policy in state I at time t. So that's V with a subscript of t in front of it. That's a standard notation for reserve at time t. And the superscript I denotes being in state I at time t. We are given that the reserve at time 3 for a healthy person is 1304.54, and for a disabled person at time 3 is 7530.09. We're supposed to calculate the derivative with respect to t of the reserve at time t for a healthy person. Okay, and of course you should immediately think the Thiel's equation, because that's the only equation where the derivative of reserve is considered. So you should memorize the Thiel's equation for the multiple decrement case that we have here, because the person can die or become disabled. Now, your company is considering adding an additional feature to this product. Under this additional feature, the insurer would return the sum of the premiums paid at the end of 10 years without interest if no benefit were paid during the life of the policy. Calculate the increase in the net premium rate payable continuously for the product as a result of including this feature. I mean, note one thing here. You can't assume that the part of the premium, let me put it differently, that you can just add the premium for this survival feature, because there's going to be a payment of the premiums at the end, return of the premiums. And you might think, well, I'm just going to add something for that payment of the premiums. I already have the premiums, so that's going to be easy. No, because the premium that you're calculating will pay for itself, not for the return of the premium that we have from the previous calculation, but for the return of the new premium. The new premium will be higher, and then, because there's a return of the premium, and then it will be made even higher because it needs to pay for itself being higher. Okay, so let's look at solving this problem. The part A says that we want to show that the sum of these annuities payable in various states ends up being this deterministic annuity. Okay, so you just need to remember what this symbol means. This is an annuity payable continuously from time 0 until time 10 for life age X, now in state 0, that's what this superscript of 0 is for, but it's payable while that life is in state J, that's the second superscript. Okay? The definition does not require that the life stays in state J without interruption. It would be kind of strange if it did, because it starts in a different state, possibly, if 0 is different than J. It merely says that for the entire time from age X until age X plus 10, while the life considered is in state J, payment is made continuously. And it doesn't say it has to be without interruption either. Now, since states 0, 1, and 2 are the only possible states, at any moment in time between time 0 and 10, this life is going to be in one of the three states. No other state can happen. So the sum of those annuities over all three states is just a deterministic annuity paid continuously for 10 years, because at any moment in time, one of the three payments has to be made, and they exclude each other. They can't be paid together. So that means that the sum of these annuities is a deterministic annuity. This is part B. We want to show that the net premium rate for this policy is 970 per year to the nearest 10. You should calculate the rate to the nearest 1. We're going to do even more precise calculation, but anyway, we want continuously payable net premium, and net premium the same as benefit premium. That means we will be doing the calculation using the equivalence principle. So using the equivalence principle, we set up the actual present value at policy inception of the premiums equal to the actual present value at policy inception of death, actual present value of death benefit, and actual present value of disability benefit. Now these annuities representing how the premium and disability benefits are paid are a bit complicated, but those values are given in the problem, so it's simplified. But otherwise we would have to be careful about leaving state 0, going to state 1, and then returning, and so on. All this is given. So this is an equation with p bar being the unknown. We solve it for p bar. Notice that we don't have the value of a bar x angle 10, 0, 1, but we just established that the sum of the three annuities in various three states, 0, 1, and 2, is the deterministic annuity. So if we subtract from the deterministic annuity the annuities paid in state 0 and state 2, we get the annuity paid in state 1. That's what we do in the first step. And then we just plug in the values. The life insurance benefit value is given. Of course, it's 10,000 times the value per unit. The deterministic annuity, that's just 1 minus v to the nth over delta. You should know this from exam FM. And then the other two are given. We plug in everything, we have the answer. And it's approximately 967.08 or 967 to the nearest 1. And of course, this is 970 per year to the nearest 10. Now here's part C, where you're supposed to calculate the value of the derivative with respect to t of reserve at time 3 for the healthy life. Now, of course, it immediately suggests the Thiel's differential equation, and it's equal, well, the differential equation says that the rate of change of the reserve at time t for the healthy life is the premium. The premium increases the reserve, because remember, the net premium is basically the part of the premium that pays for the benefits. When it arrives, you can think about it immediately going into the reserve, and then the reserve pays out the benefits. The benefit premium, when it arrives at the insurance company, it's immediately, the actuary grabs it and says, you can't spend it, it's reserved, don't touch it. So the reserve goes up with the premium. Also, the reserves earns interest, and it's continuous process, so at the rate delta. But when the person dies, and the force of mortality in this case is mu x plus t upper 0, 2, because 2 is death, the state 2 is death, and this is the force at which we're moving towards it. The payment is made, and the amount of the payment was the death benefit, but we already have the money for it in the reserve, so we pay out the reserve from the reserve. So the extra that we have to pay, that we really lose money on, is the net amount at risk, so $10,000 minus the reserve. And then person may also leave the state 0 by going to state 1, the disability, and then what we need is to have a disability reserve instead of death benefit, but otherwise it's the same process. We need to come up with extra money to pay for disability reserve, but we already can use and have and can use the life insurance reserve. So that's what this equation basically says. And we know the premium, we know delta, we know the values of the two reserves, we know the forces. So we just plug in everything, and it's all just calculation, and we have the answer of 326.78805. Now, part D is a little bit longer. I reproduced it here fully. Your company is considering adding an additional feature to this product. Under this additional feature, the insurer would return the sum of the premiums paid at the end of 10 years without interest if no benefits were paid during the life of the policy. Calculate the increase in the net premium rate payable continuously for the product as a result of including this feature. Okay, so this new situation amounts to adding a survival benefit payable after 10 years if the person remains healthy continuously throughout those 10 years. Continuously. Because if the person becomes disabled, then the disability benefit is paid, and that nullifies the survival benefit. Because the survival benefit, as the problem says, is only payable if the person does not receive any other benefits. The amount of benefit is the annual premium paid over 10 years accumulated without interest. It's just annual premium times 10. But it will be a new premium, and we'll call it P bar star, because the survival benefit depends on the premium, obviously. But this premium will also pay for the new survival benefit, so it will have to be bigger. So we again need to set up an equation based on the equivalence principle, but this time it will include also the survival benefit, and the survival benefit will be paid with what probability? Well, the probability of surviving continuously, so never leaving the state, surviving continuously in state 0. And that probability is denoted as you see here. It's 10 years, probability for X surviving in state 0, starting from state 0, with a bar above 0, 0 indicating that we never leave state 0. And that means that the person is completely spared the force of disability and the force of mortality acting on them, and that probability is the integral, e to the minus integral of the sum of those two forces. Okay, the first force is 0.04, the second one is 0.02t. We take the integral. It's easy to take the integral of a constant, 0.04 over 10. That's just 0.4. From 0 to 10, there's over 10 years. And then we take the integral of 0.02t, which is 0.01t squared, and evaluate it from 0 to 10. At 0, that function is 0, but at 10, t squared is 100, and what's 100 times 0.01? It's 1. So we have negative 0.04 minus 1, so the probability is e to the minus 1.4. Now, we set up the equivalence equation, and what do we get? Well, the premium on the left-hand side, paid as an annuity while the person is healthy. Now, there's no requirement here that the premium is paid as long as the person is continuously healthy. No, it's while the person is healthy. Nothing changed in this. So it's the same as before, but it's a new premium. It pays for the death benefit and it pays for the disability benefit, just like before, but it also pays for the survival benefit. The benefit is 10 P bar star, and it's paid with probability e to the minus 1.4, and its present value at time 0 is obtained by multiplying it by discount factor, which is e to the minus 0.1 times 10. E to the minus 0.1 times 10 is e to the negative 1. E to the negative 1 times e to the negative 1.4 is e to the negative 2.4. Okay, so we solve this for p, and we get what you see here, which is very similar to what we had before, but we subtract 10 e to the minus 2.4 in the denominator. But we basically do the same calculation with this one thing subtracted in the denominator. And we obtained 1,211.95. And of course the premium is bigger, as we expected, and the difference is 1211.95 minus 967.08, or 244.87. Please remember that these exercises are copyrighted. You cannot reproduce them without my permission. I also need to stress that the text of the problems from the Society of Actuaries examinations is the intellectual property of the Society of Actuaries, are produced with permission, but I don't have a permission to give it to you in any way. I'm just showing it. And good luck in your studies.